advanced learning targets. I can calculate trig values without using a calculator. Okay. I can explain all the aspects of the unit circle and use it to calculate information that I need. And a little bit of review from Algebra 2 with trig. But a lot of people tend to forget. Just did that and I had to click. I don't know why I just did that. Anyways, find the following without a calculator. Find the following without a calculator. So, sine of negative 210 degrees. Sine of negative 210 degrees. So the first thing we're going to do is what? Yeah, let's plot that. So if I start, anyone remember what this side is called? The beginning. It's the initial, right? Starts at 0 degrees, you have 90, we have 180, we have 270, and back to 360. Okay? Now, where is the terminal side of this going to be? What quadrant? Yes, the second one. Then you might say, well, 210, should that be here in the third one? No, because it is negative, which means we will go clockwise. So this becomes negative 90 degrees. This becomes negative 180. This becomes negative 270. And this, I guess, negative 360. We can say that. And negative 210 is in this quadrant right here, quadrant 2, the top left. I don't know, it's a little bit closer to 180, maybe right there. That looks almost in the middle, but. So from here to here, that is negative 210 degrees. Right? So, what other piece of information do I want to find right now that's going to help me right here? Remember? I want to make a right triangle. Okay, so let's do that. I like that.
I'll draw altitude.
We're going to draw altitude. Perfect. There's my right triangle. But what else should I need? Okay, sorry about that. Well, what was that? Well, we have the 90. What else do we need in that triangle? Start finding. We need what? Yeah, two other sides. So where would that be? What do I need here? Well, I need sine, right? I need sine. So I'm going to find the sine of this angle right here. I need the opposite of the hypotenuse. So how do I get those? I don't have any sides. No. So how can I find this angle right here? How can I find that angle right there? With the angle I'm given and the terminal side. Well, if my angle is 210 degrees, okay, it is 30. And it passes 180, 30 degrees. It is a 30, 60, 90 triangle. Perfect. Now I can find opposite hypotenuse because I know what the sides of 30, 60, 90 triangle are. They are what? Radical 3.
Radical 3, 2, and 1.
Radical 3, 2, and 1. But where do they go? 2 is a hypotenuse. 2 is a hypotenuse.
Radical 3.
Yes, it'd be the adjacent side. You're right. Radical 3. And this is 1. And how can we remember that based on the angles? 2 is the biggest side. It should be across the biggest angle. That's a review from geometry. Smallest angle, smallest side. The middle angle, the middle side. Radical 3 is actually less than 2. You got it. So now, how do I know what the sine of that angle is? It is opposite over hypotenuse, which would be 1 over 2. And what's the last thing I need to check? In this case, this happens to be the answer. But how do I know if that's positive or negative? Check the quadrant. Because all students take calculus, right? Right. Yeah, you laugh. You kind of laugh. Yeah, and what does that S represent? Sine is positive. If we're taking sine, that should be positive. And some other students do it this way. Well, the x value is negative in this direction, isn't it? So that would be a negative radical 3. The y is positive in this direction. It's a positive 1. And our hypotenuse is always positive. So it's positive 1 over positive 2. We're good to go. All right? All right. I wish. Find it without a calculator, the tangent of 5 pi over 3. So let's use the unit circle. The first thing we should do is, I would convert this to degrees. That always makes things easier. So if I have 5 pi over 3, I multiply by 180, perfect, over 5. All right? Cancel. 3 goes into 180 60 times, and 5 times 60 is 300. Good. So I need to find the tangent of 300. Questions? Any questions? Okay. Let's do that. Then you got to divide by 3. All right, so I got to plot 300. What quadrant is 300 degrees? It's the fourth quadrant, because we are going in a positive direction now, right? We're going in a positive direction. So, I'm going to come back to 360 here. Comes all the way around here, past, and a little bit like that. Wait for it. Wait for it. We're just going to label this. This is 300. Good. So far, so good. What about the tangent of that? I still want to draw our what to create a triangle? Our altitude. I'm going to draw something like that. Now, everything is to the x-axis. One of the biggest mistakes that people make is they will draw their altitude this way. That is wrong. We don't want that. That is wrong, wrong, wrong. Bang, bang. Question? Yes. Because not only does our altitude get drawn to the x-axis, the angle we want is the one to the x-axis. I don't want this one here. That's wrong. Everything should be to the x-axis. So this is 60. That's right. This is 30. I don't know that's 60. Well, a full circle is 300. We take 300 out of that, and we're left with this wedge right here, which is 60. And you guys just told me that the size of that triangle, well, 1 is across from 30, radical 3 is across from 60, and the hypotenuse is 2. I want the tangents. So what is tangent? It's what letter over what letter? It's opposite over adjacent. Okay, well, based on our 60 degree here, what is opposite? This is opposite. What's adjacent? What's adjacent? So it's radical 3 over 1, which is radical 3. $1 million question, positive or negative? It's negative because, students take calculus. You want to adjust that? Cosine is the only one that's positive there. Well, cosine and what else? What's the reciprocal of cosine? Secant. Cosine and secant would be positive there. But tangent, cotangent, sine, and cosecant, they're negative, which means this has to be negative. How else can we do that? Well, this is positive. Our 1 is a positive one. It's going this way in the x-axis. It's positive, right? But our radical 3 is going down on the y, so it'll be negative. It'll be negative. Radical 3 will. See, to me, that seems easier sometimes instead of remembering more little tricks. I mean, that's just an obvious. You guys know how to plot coordinates. So, but either way, you can check it. So if I put this in the calculator, what do we say radical 3 was? 1 point something, 7 something, wasn't it? Yeah. So if I do this, I should get a negative 1.7 whatever, whatever. So I'm going to clear this up out, and I'm going to go to mode because I want to make sure I'm in degree mode. I happen to be in radians. Okay? Yeah, that'll mess you up. So if I take the tan of, what do we say, 300? And there we go, because the negation of radical 3, that's what it is. I mean, it's perfect. I love it when it works out. And you should too, because that's how you get A's, children. And yes, Donovan, you are correct. We have secant here. All right, but when we do our triangles, you know, it's all with relation to sine, cosine, and tangent. But as Donovan said, cosine is the reciprocal of secant, isn't it? So if cosine is adjacent over hypotenuse, I can find secant by taking hypotenuse over adjacent. So the same rules are going to apply. And again, where cosine is positive, which is the fourth quadrant, and secant is also positive. Because when I take a reciprocal of something, I don't flip the sign, I don't negate it. I just flip the numbers. If it's positive, it still stays positive. If it's negative, it still stays negative. So we just got to figure out, to make life easy, what is this in degrees? I know it's going to be negative. I think you are absolutely right. Now, some people multiply that by pi over 180, and some people just know, if I was in radians, how many degrees is pi? Is that 180 in the middle? So I could technically just put 180 in for this. It's the same thing. So I get negative 3 times 180 over 4, and 4 was 180 45 times. So negative 3 times 45, you're absolutely right, negative 135 degrees. So I want to find the secant of negative 135. What quadrant is that terminal side going to fall in?
3.
Quadrant 3. This is my initial side. Starts at 0. It's negative now, negative 90, negative 180. And of course, negative 135 is right between there. So I'll just, from here to here, bang, negative 135. Very good. Now, again, we want to draw our altitude, we want to get our angle, but it's all to the x-axis. Don't do it to the y-axis. So, here's our altitude. We know it says 90. And I will give you guys a minute to finish this one off on your own, and then we'll go over. So, you guys are telling me, what did you get for an answer? You're saying you got negative radical 2. Let's see if this is correct. All right? So, first thing is, after our altitude, you need to find this angle here. What is that? 45. So the difference between 135 and 180 is 45, which means we have a 45, 45, 90 triangle. And the sides of a 45, 45, 90 triangle are 1, 1, radical 2. Thank you very much. All right? So, if we are going based on this angle, opposite of that is our 1. Adjacent of that is our other leg of 1. And our hypotenuse is radical 2. We are hypotenuse over adjacent. Radical 2 over 1. So if I get radical 2, that doesn't match your answer. And how come? It's, yeah. Thank you. Tangent is the only positive trig function in quadrant 3, or cotangent. Okay? Cosine and secant are negative, so this is, in fact, negative. And again, if I move to the left on the x-axis, that makes this one a negative. If I move down on the y-axis, it makes this one negative. Okay? My hypotenuse is always positive. So it's positive 2 over negative 1, which indeed is negative radical 2. Good. Not too bad. So, the unit circle. We've been using this. We've been going over it, using it for to solve for information for sine, cosine, affine trig, to draw angles in standard position, etc. But this is a quick refresher, and maybe we should have started with this, but we're ending with it. How do we label the degrees? Well, this always starts with 0, and if we go counterclockwise, we just go up by 90s, right? And if we are going in the opposite direction, if we're going in the opposite direction, it negates, right? So this would be negative 90, negative 180, negative 270 up here, and negative 360. All right? So how do we label degrees? That's how we do that. All right. If you want to do radians, let's get crazy here. This is, what is 90? Yeah, it's pi over 2, and I'm going in a positive fashion. What is 180? Pi. What is 270? 3 pi over 2. And what is 360? This would be 2 pi or 0 pi, whatever. So that would be radians. And again, if we negate it, we would just do opposite. Now, how do we know what trig function is positive, negative, and which quadrant? We've just been discussing this. Yes. All students take calculus. Okay? Which means the A stands for what in quadrant 1? All trig functions are positive there. What about quadrant 2? Sine is the only positive. That means cosine and tangent are negative. And the same thing holds true about the reciprocals. So if sine is positive in quadrant 2, so is cosecant is also positive. That means secant and cotangent are both negatives. Okay, negative. What about quadrant 3? The T is for? Tan. Tan is positive. That means sine is negative and cosine is negative. Last year, when we had to kind of solve for trig equations, wasn't tangent equal to sine over cosine? Remember that? So sine over cosine, if I created a fraction, is that a negative over a negative?
And you do positive.
Gives you positive anyways. And it all just keeps on working. In quadrant 4, cosine is the only positive. That means sine is negative, tan is negative. Alright? But here's the cool part. This can save you a lot of work if you remember it. What is so special about the coordinates of a point on the unit circle? This circle right here, okay? We've really just been using the axis to find angles. We really haven't been using the actual circle. Now the circle's on, all right? So here's our circle, right here. Now this is a radius of 1. It's a radius of 1. So for the sake of spacing, we're going to erase these degrees and all this other junk here. What would be the coordinate? What would be the coordinate? All right, right here at 0 degrees. What's that coordinate? If there's a radius of 1, 1 comma 0. Which means at 90 degrees, what would this coordinate be?
0, 1.
0, 1. Better than 0, 1. So at 180 degrees, what would this coordinate be? Negative 1, 0. And at 270 degrees, what is this coordinate? 0, comma, negative 1. Now, what is so special about those? You ready for this? Whatever my coordinate is, all right, the x value is always equal to the cosine of that angle, and the y value is always equal to the sine of that angle. Meaning, let's look at 180 degrees. If I ask you, what is the sine of 180 degrees? Look at my coordinate. This is right at 180 degrees, right?
Yeah.
What's the sine? What's the y value? What's the y value here?
0.
0. Because doesn't my sine graph, here's 180, here's 360, here's 270, and here's 90. Doesn't sine go up, come back, touch, go down, come up? Well, what's the sine of 180? It's 0. What's the sine of 90? 1. So guess what my y value is at 90? Holy smokes, look at that. What's the cosine of 270? So I'm looking at my computer screen. Cosine.
0.
0. 0. That's it. That helps out big time when you know stuff like that, okay? Mm-hmm. There we go. So let's start doing this stuff. A couple more. Okay. plot 300 degrees in the unit circle, and without a calculator, calculate the point of intersection between the terminal side of the angle and the unit circle. All right? So, let's start by plotting 300 degrees. Wait for it. 300 degrees we did before was right here. Go through this. This thing right. 300 degrees. That's 300. Bam. So they want us to get the coordinates of this point right here. What do you think they're going to do with it? Well, in order to find the coordinates, isn't the x the cosine of that angle, which is 300? And isn't the y the sine of that angle? You got it. Which means like, wait, no. Without a calculator, it says. Don't start getting crazy now. I draw my altitude, don't I? How many degrees is right here? It is 60. Because if a full circle is 360 and I'm 300, I'm 60 short. Which means this is 30. Which means this is 1, radical 3, and 2. All right? So, what's the cosine of 300? What's the cosine of that angle 60? It's adjacent or hypotenuse. This is our opposite side right here, right? This is our adjacent. This is our hypotenuse. What's the cosine of 300? It's 1 over 2, comma. What is the sine of 300? Radical 3 over 2. That's the actual coordinate. That's the coordinate. That's awesome. Now, it didn't stop. It's just one more thing. Find the distance of the tangent line. Okay? Find the distance of the tangent line. First, we found the coordinate right here. That was of where the terminal side, which is this where it ended, crossed the unit circle. This here. Now we want to know the length of the tangent line. The tangent line in geometry, in case you forgot, touches the circle at one point, doesn't it? Mm-hmm. So if I touch right here and draw a tangent line, they want to know the distance from here to here. And that's the tan of my angle. Because if the coordinate is the cosine and the sine, well, the distance of the tangent line is the tan. Well, they want it without a calculator. Didn't Visca just tell you that tangent? It's sine over cosine. Well, we have a coordinate here, don't we? That's radical 3 over 2 all over 1 over 2. The 2's can cancel. So you get radical 3. That's the distance. And it happens to be a positive value. But if they want distance, the distance is always positive. If they ask you the value of the tangent, it'll be negative. All right, let's take a look at this. Okay, let's see how much sense this makes. Okay, the cosine, here's the coordinate. The x value is at 1/2. Let's see how good we drew this. If this is 1 from here to here, half is, I don't know, maybe halfway. Right out there, we're off slightly. But that's not bad. I mean, look at that. It's almost close. Made that big dot so it looks like what it's supposed to be. The y value would go down, if this is 1 down here, -1. Oh, what do we do with our y value? That should be negative. Isn't sine negative in that quadrant?
So it's negative around.
So the coordinate, which would mean tangent is negative, which would mean this should be negative. But distance is always positive. Okay. Value can be negative, but distance is positive. All right. So that's what we say, negative 1.7 over 2. I mean, it's almost like negative 0.8, negative 0.75, somewhere around there, 775, 735, like that. So, I mean, that's about 70 to 80% from here, right? Here's -1. I mean, that looks like it's closer to that value. Which means this should be negative 1.7. This tangent line should went a lot farther down, maybe a little bit farther, but you know, we do it by hand. It definitely goes deeper than negative 1. And it is past limit, so I think it's going to make sense. All right. Now, we did A, B, and C already, so we're just going to do D and E. F kind of has the same concept. Without even plotting negative 270 degrees in the unit circle, how do I know what the sign of negative 270 is? First of all, where would negative 270 be in our unit circle? It would be, where 90 is the same as negative 270. If I wanted the sign of that, the sign is what? What's the sign of that? Remember, it's the y value of the coordinate, right? Isn't that at 0, 1? So it's 1. The sign is the y value of your coordinate. 1. Right. It's the sign of 90. Same thing, sign of 270. Now, the tan of 3 pi. Let's put that into degrees. That's 3 times 180, right? Which would give us what? 540 degrees. Now, how do we do that if we have 90, 180, 270, and 360? Well, here you go. If I started here, this is my initial side. I go around once, that's 360. I go here, that's 450. Then I go here, that's 540. That's a full circle and another half of the circle. See what I'm saying? That's 360 plus 180. So that would be 540. But guess what? Here's the terminal side. What is the tangent of that? Well, what's this coordinate? That coordinate is what? Negative 1, 0, which is the cosine and the sine. Well, what is tangent? Isn't tangent sine over cosine? 0 over 1, so it's 0. Good call. But if I was looking at your answer, it's still be correct. So you see what I'm saying? If it goes more than 360, well, just go to 360 and keep on going. All right? Technically, if it's bigger than 360, just subtract 360. And what do you have left? 180. Guess what? If you subtracted 360 and you have another 360 left, subtract another 360. That would be at 0. 720 degrees. We're not gonna, well, then you get the concept. We are done. Homework on this tonight.